everyone, welcome to Passnownow's preparatory class for SSC. I'll be your chemistry tutor, and today we're going to be treating some questions which students have had issues with in the past, such as topics like organic chemistry, mass-volume relationships, and so on. We'll begin with 2017 theory question 3A. The equation is displayed on your screen. We are asked I, what type of reaction is represented in the equation? Write the molecular formula of X. Draw the structure of the two isomers of X. Name the isomers drawn in 3AII. And then the last question, write a balanced equation for the reaction between X and hydrogen. The I question asked, what type of reaction is this? Now, how can we determine what reaction this is? We know that one hydrocarbon is being broken down to another hydrocarbon. This has to be a cracking reaction. And a cracking reaction is a reaction that involves the breaking down of a larger hydrocarbon into lighter hydrocarbons in the presence of a catalyst. And our catalyst here is aluminum oxide. Hence, the answer for this is catalytic cracking reaction. Question II. What is the molecular formula for X? How do we find the molecular formula for X? It's simple. We're going to subtract the number of carbon atoms here from that of this, and the number of hydrogen atoms here from the number of hydrogen atoms here. For carbon, we have 12 minus 8. This will give us 4. And for hydrogen, we have 26 minus 18 to give us 8. Therefore, the molecular formula of X is equals to C4H8. The III says to draw the isomers of X. Now, how can we know the isomers if we don't know what this hydrocarbon is? We can determine that by first finding the number of carbon atoms. We know X has 4 carbon atoms, meaning that it has a prefix starting with but. So it is a but something, but N, in, or I. How do we find out there's that group of hydrocarbon this falls into? We know that alkanes have the molecular formula CnH2n plus 2. The alkene have the molecular formula of this. And the alkynes have the molecular formula of this. Now, since we know carbon here is 4, from here, hence, our X is a but-in. So now, with this taken care of, we can find or draw the isomers of X. Now, we know that alkenes have a carbon-to-carbon double bond, meaning every isomer we will draw for X must have a carbon-to-carbon double bond. We'll start by first writing 4 carbon atoms. Now, we'll look for a position to place the double bond. We can place it here. Each carbon atom is supposed to be attached to 4 hydrogen bonds or 4 bonds, as the case may be. Now, this particular carbon, we just have 1 hydrogen atom. Why? Because we have 1, 2, 3, 4. It has 4 bonds, so it's complete. For this, it will have 2 hydrogen atoms attached to it. And after counting it, we have 1, 2, 3, 4 bonds. So this hydrocarbon, if we're naming it, we have to start from the end because it has the double bond attached to the end, the carbon 1. So this will be but. This carbon atom will be, this hydrocarbon will be but 1 in. That's one isomer. So for another isomer, we'll take this double bond here. Now, since we have our double bond here, how do we name this? We'll start from any end. You can start from here. 1, 2, 3, 4. If we're naming this will be but 2 in. So this is another isomer of X. I'll give you an expo and write another isomer, which is 3. So you can pick any one of the isomers, any 2 out of the 3 isomers and draw them. Now, how do we name this? We'll start from the end with the double bond. This is 1, 2, 3. For our carbon 2, we have a methyl group attached to the carbon atom. So we'll name this starting from 1, 2, 2 methyl, since this methyl group is attached to our carbon 2. The name will be 2 methyl 1, 2, 3. The longest carbon chain, which is 3 carbons. So it's a propene. So the name of this structure is 2-methylpropene. Now, the question 3A IV says to name the isomers you've drawn. We know that our first isomer is called but 1 in. The second, but 2 in. And the third is 2-methyl. Propene. I hope you understand. The last question on question 3A says to write a chemical equation for the reaction between X and hydrogen. We know X is C4H8, hydrogen. Hydrogen is diatomic, so we can't just write hydrogen and leave it there. We have to write H2. Hydrogen is diatomic. Now, we know that alkenes are unsaturated carbons, and hence they will undergo addition reactions to form saturated carbons called alkanes. This is a hydrogenation reaction, which is an example of addition reaction. So this will react with this to give us butene will react with oxygen to give us butane, which is a saturated hydrocarbon. Our next question, the same 2017 question 3C. The question reads, sulfur 4 oxide is converted to tetraozosulfate 6 according to the following equation. If 1.5 moles of oxygen reacts with sulfur 4 oxide, calculate the mass of tetraisosulfate 6 acid produced. This question asks us to find the mass of tetraisosulfate 6 acid produced. How do we go about this? First, write the mole ratio. If 1 mole of oxygen reacts with 2 moles, or if 1 mole of oxygen reacts to yield 2 moles of hydrogen tetraisosulfate 6 acid, 1.5 mole of oxygen will yield, if we cross multiply, this 2 times 1.5. This will give us 3 moles of hydrogen tetraisosulfate 6. Now, it doesn't end there. We have to look for the molar mass of tetraisosulfate 6 acid. To find the molar mass, we have to add the relative atomic masses of hydrogen, sulfur, and oxygen. Since we have 2 hydrogen atoms here, we'll have 1 times 2 plus the relative atomic mass of sulfur, which is 32, plus 16 times 4. This will give us 64. 2 plus 32 plus 64 gives us 98 grams per mole. So that is the molar mass of hydrogen tetraisosulfate 6. Now we can find our mass. Now, to find the mass of hydrogen tetraisosulfate 6 acid produced, formula for mass is number of moles times molar mass. The number of moles of hydrogen tetraisosulfate 6 acid produced we found to be 3 moles, and the molar mass we calculated to be 98 grams per mole. Now, to find the mass, 3 moles times 98 grams per mole. This par here means is divided by, this grams divided by mole. Now the mole here will cancel out the mole here. This will then give us 3 times 98 grams. Hence, the mass of hydrogen tetraisosulfate 6 acid produced is 294 grams. Now, endeavor to show all the steps taken so that whoever is marking your script knows that you know what you're doing. Thank you. Our next question is the same 2017 question 3D. The question reads thus: consider the following neutralization reactions as displayed on your screen. I. Arrange the enthalpy changes for the reactions in order of increasing magnitude. II. Explain briefly the order in 3DI. The I part of this question asked us to arrange the enthalpy changes for the reactions in order of increasing magnitude. Okay, so neutralization reaction is a combination of hydrogen ions and hydroxyl ions to form water molecules. This first reaction is a reaction between a weak acid. This is acetic acid. It's an organic acid, and we know that organic acids are weak acid. A weak acid is reacting with a strong base. A weak acid and a weak base will undergo complete ionization. A weak base and a weak acid will undergo partial ionization. And a weak acid and a strong base will undergo partial ionization. Now, this will come first, the second reaction. It will have the least enthalpy change because it is a reaction between a weak acid and a weak base. The next will be our first reaction, which is a reaction between a weak acid and a strong base. Then the one with the highest enthalpy change of neutralization will be that between a strong acid and a strong base, which undergoes complete ionization, which is our last reaction. The order of increasing magnitude is the second reaction, followed by the first, and then the last. So the last will have the highest enthalpy change. So we've come to the end of today's session. I hope you guys understood everything we taught here today. I will indulge you guys to go back to your past questions and solve likely questions such as these, so you get familiarized with the structures and be able to solve them on your own. Thanks for staying with me. Bye guys.